Good morning, everyone. In the last session, we discussed about the exceptions informations here. We identified the multiple exceptions and the chained exceptions. We tried with nested exceptions. All the concepts we discussed up to the yesterday. So today we are going to discuss about the one of the important concept to call multi-threading here. So this is the one of the important concept we are discussing here. So basically, Java will provide the built-in support for the multi-threading here. If you're not using the multi-threading concepts here, so built-in Java will provide the multi-threading concepts here. But if we want to write an efficient program to come up with a multi-threading program here, now we need to follow some syntaxes and guidelines here. How this particular multi-threading is going to work internally. Okay, so this is one of the important concepts we are going to discuss in our today's session. So basically, multi-threading is nothing but we are going to run the multiple threads at a time. For example, we have a one e-commerce applications. Okay, so when the e-commerce application is running on the over the world, what happens is we are going to get multiple requests here. Okay, we cannot imagine how many requests we are going to get. So those requests basically we are going to divide into the multiple threads calls here. So each request we are going to make as a one thread call, and it will try to perform the specific operations here. So it is not going to perform the common operations here. Okay, this is one of the important example we need to understand here. Getting the point. So finally, what we are doing here, so to come up with the thread-based related application, first one we need to understand the basic concepts, how it is going to work here. Okay, basically, so as I explained here, when this particular thread is going to execute here, it is going to contain the specific path of execution here. Whenever the thread is enabled here, it's not going to communicate with another thread here directly. It will try to connect with a separate path of execution here. Okay, so this is one of the important example we need to understand here. When this particular thread it is contain the separate path, what happens internally? So it can access only whatever the specific information which is available for this particular thread here. Okay, this is important here. For example, we have a 4 threads are running here. Okay, 4 threads are running. So this is contain the specific path, and the same way all the remaining 3 also it's contained. It cannot go into this particular threads here. Okay, it does not identify, like it does not know how many the remaining threads are running here. Getting the point. So each thread it is not going to depend with another thread here, because so it's contain the internally the separate path of executions here. Okay, this is important here. And now if we observe carefully, all the nowadays, like all the modern operating systems are using our multi-threading concepts here, because so basically each thread it is contained with a different path. For example, one thread I open with a IDE, and another thread I open with something like a notepad, or another thread I open with our join me up. Getting the point. So same way we are going to contain with the different threads here. We are going to connect with the differences. So this is the way all the modern operating systems, like whatever the operating system now they are developing, they are trying to implementing our multi-threading concepts here. Okay, not only this, all the banking sector, finance sector, e-commerce sector, getting the point. All the public related websites, whatever the public domains we are going to have, all the public domains they are internally implementing on the multi-threading concepts here. Okay, this is important here. Now you can think how much this particular the multi-threading is important internally. And here, so before going to discuss about this particular thread concept here, first we need to understand the process concept here. So process basically what it will do, process is one of the like execution, like how the thread is going to work, same way the process will work, but only the difference is internally it's going to contain, like it's going to consume the more memory. Whatever the thread is going to consume the less memory compared to this particular thread, basically process or internally it consume the more memory, and it will not contain the separate path of execution here. So because of this process drawbacks here, now internally what has been introduced, the thread concepts is introduced here. Okay, so if I want to create a thread internally, what we will do, we'll try to come up with a either interface as well as we have one class. With help of this particular two concepts here, we'll try to implement the thread informations here. Okay, so this is we need to understand very carefully here. As I explained here, the thread is one of the smallest unit of the dispatchable here. It is not going to take much memory to execute the all the code whatever we implemented here. Okay, the single program along with this, the thread basically the single program can contain the multiple. So it's like the single program can run simultaneous operations here. This is very important. Whatever the program we are going to write here, the program it can run the simultaneous operations here. So concurrently, it will try to run the all the programs here. So this is one of the important example we need to understand here. Okay. So as I explained here, the processor heavyweight, so they are not going to contain their own space address here, and the context is basically the threads basically internally will contain the separate path. Okay, and we need to identify the less memory inside this particular thread here. So along with this, we are going to discuss about the thread model. Thread model basically it contain the grouping information. So which group by default we are going to use, and what are all the threads we can create in the group related concepts we are going to discuss once we familiar with this particular threads concepts here. Okay, the group also one of the important concept we have inside this particular thread. Along with this particular grouping concept, we have another important concept called thread priorities here. So what are all the priorities we are having? So basically, you can provide the custom priority between 1 to 10. Okay, between the 1 to 10, we need to provide the priority here. So this is one of the important here. So whatever the priority we are going to provide, this should be between this, and then only then only our compiler will give you the highest option to the highest priority threads here. But this basically is implemented on the thread scheduler. So we are not going to provide the getting the point. We are not going to think about the informations like how the threads are going to run concurrently, because everything is going to handle by the thread scheduler. Because of this particular thread scheduler, what it will do based on the highest priority, scheduler will give you the priority to this particular threads here. Okay, so this is the one of the important concept is introduced in our threads class, that is called scheduler here. Okay, so along with the thread scheduler, we'll try to identify the synchronization. Getting the point? We'll try to identify the synchronization. So how this particular synchronization is going to work. With this also we'll identify here, and later we'll try to identify the differences between thread class and runnable interface. Okay, so as I explained here, we can create a thread with the help of two options. First one is implementing this particular runnable interface, and extending we have a one class called thread. Getting the point? So this is we'll use the implements keyword because it is a interface here, and thread is a class. So here we are going to use the keyword called extensive. So this is the important information we need to understand here. By using this particular interface, we can create a thread, and by using this particular thread class, also we can create a thread here. Okay, we'll see the differences here, and which one is the highest, like which one is suitable, and which scenario we can go for the either runnable interface or the thread class here. Getting the point? These are all the important concepts we are discussing here. Now observe carefully. First, I will try with the current thread example. So what is the current thread basically? So once you're familiar with this particular current thread, we can easily understand about the custom threads creations. Okay, so let's observe the simple example. And here I'm going to write the package. The package basically it is contain the multi-threading example. So why I'm writing these many packages here? If I commit this changes, because the packages internally, it's give you the structure of the code here, so that we can easily understand here based on this particular package, we'll get to know what are all the classes we defined, like what are the classes we identified in the previous example. Okay, so now what we need to do here, I'm going to write the current thread demo. So first I will try to identify the what is the current that we are having. Okay. So after this we'll move on to the custom created threads here. So now observe carefully. We have a one method. We have a one method using this particular current thread. We can identify how the current thread is returning here. Now you can see. So this is the current thread method we are having. Getting the point? This is the current thread method we are having. So this particular current thread, what is doing internally, it is trying to return the thread object. But here now if you observe carefully, we are not creating any object here. Okay, here we are not creating any object. So why we are not creating? Because we have a option to call one of the static method. Now observe carefully. So just for understanding, just for loading the current thread information, now what we are doing here, we define with a static method and something like a current thread. The current thread we are calling here, getting the point? The current thread we are calling, and internally it is trying to return the thread object here. So this particular thread object internally, it is contain the information about the name of the thread information here. So for example, here I'm going to print this out here. Current thread I'm defining, and here I'm trying to write the thread here. Okay, so I'm not writing much code here. Now you can see. So what is the current thread we are having? Here you can see the information here. This is important. So current thread we define the message, and this is the thread information here. Okay, what is the name of the thread we are having? Main. So who is created this? Getting the main method is calling from the where? Inside the JVM we are going to create the main thread, and we are calling, after creating this particular main thread, we are calling the main method here. Okay, and the same way, now observe carefully the name of the thread we are having main. Okay, so this is the thread name, and this is the priority. So this is the thread group here. So we are having three informations. First one, what if we are discussing here? Something like name here. And the second one, it is a priority. And third one, what we need to understand, it is basically group name. So this particular thread, it is comes under the which group here. Okay, it is comes under the which group. So these are all the three information we are able to identify whenever I'm trying to print this particular thread. It is nothing but the current thread. Basically, the line number 8, is executed by the current thread here. Okay, and how we are getting this information? What we need to understand here? We need to identify the important section called toString method. The toString method, we can easily understand what the information we are having inside this particular, what information we are having inside this particular thread class. Okay, if I'm going to expand this, this particular thread class, and it is internally, it is extending from this particular runnable interface here. We'll see later the runnable interface. Now focus more onto the toString here. So I'm trying to expand the first toString method, because the toString only, it is giving the object information. Now you can see. So observe carefully what they are doing here. They are trying to add the thread here. Getting the point. So now you can see 1454 line number. We are trying to return the thread here, and we are trying to enable this particular, okay, the brackets basically, and this particular bracket internally, it is contain the name of the thread, and it is contain the priority, and it is contain the thread group name. Okay, so if this particular group not equals to null, if not equals to null, we are adding the thread group. Otherwise, so only name of the thread, priority. Only name of the thread and priority we are having. Getting the point? So this is the important information we need to understand here. Getting the point? So this is the way we are defining the current thread information. Now if you are interested to write this particular toString override, now you can define whatever we want to write here. Okay, so this is the information we need to understand how this particular the message is printing here. The message is printing because of this particular toString method here. Okay, so now we identify the simple example on the current thread. What is the current thread we are having? Something like a main, and it is having the priority call 5. Okay, so this information is fine. Now what I am doing here? Here what I am doing here, I am trying to add some additional method. So set to name here. Set to name. Here I'm trying to modify the name of the thread. So I'm trying to modify the name of the thread. Now observe carefully. Now what I'm doing here? Here I'm trying to provide as a my thread. So after modifying this particular name of the thread, now what we can do? You can print the same message one more time. You can print the same message one more time, but after the name change. Okay, after this particular name change, now what I'm doing is I'm trying to print the same thread here. Now if we observe carefully, what happening internally after name change here, what is the name is what is the name is initialized here, like what is the name is set here. Earlier we have a main method, now it is set with my thread here. Okay, it is set with my thread. This is one of the important example we are discussing here. Getting the point. This is one of the important example we are discussing here. So getting the point. Now you can see, so this is a way of writing the set name. Along with this, now what you can do, we have another option. Here only I will write thread dot priority. You can provide the priority something like we have 3 priorities inside this particular thread class. Let me write the priority thread dot max priority. You can see, getting the point, max priority, minimum priority, and normal priority. So now what I'm doing here, I'm trying to change the priority information here. I'm trying to change the priority information. So observe carefully. So earlier what is the priority? Earlier what is the priority we are having? 5 priority. And now what is the priority we are having? 10 priority. Get in the point. So how I'm modifying? Because of this particular priority method. So this particular method is available inside the which class here? Something like thread class. So don't confuse this. So this is very important here. Using this particular current thread, now I'm trying to get the thread class information, and inside this particular thread class, whatever the method we are having, I'm trying to accessing here. So name of the thread I'm using, set to priority I'm using. Okay, inside the priority, if I'm going to open, so observe carefully. So minimum priority we are having 1, normal priority we are having 5, and maximum priority we are having 10. So if you see, these are all the final variables. Okay, these are all the final variable. So we discussed the final variable multiple exams here. Now you can see how they are defining the final variable. So whenever we are defining the final variable, we need to follow the same the naming convention. We need to write the with the capital letters. We need to write this values never change. These values never change because it is a constant variable. Once we initialize these values, we discussed already, we are not going to modify. For example, if I want to modify the value, what happens internally? Here now you can see thread dot thread dot max priority is equals to, if I'm trying to give 25. Now you can see we are getting an error here. So why we are getting an error? The final field max priority cannot be assigned here. Getting the point. We cannot so modify the value. Whatever the value we initialize here, we need to use the same value. So this is the behavior of the particular final keyword. Getting the point. The final keyword at variable level. So we discuss the example, final keyword, variable level, method level, class level. So again, don't confuse here. So what exactly the final keyword will do internally. Okay, because so I explained multiple example, the up to the basic concepts here. So once you are familiar with those, you can easily understand what they defined here. Getting it? So you can open any one of the class in the our Java language files here. Now you can see. So this is the class I'm opening. The name of the class. Now you can see public class, thread class. It is implementing the one interface here. So here we are having the relation called inheritance relation, and now you can see the whatever the properties we are having, they are making as a private. So it's nothing but we are accessing the encapsulation mechanism. Okay, so here we are accessing the encapsulation information, and now you can see the constructors we are having. Okay, all the variables, whatever the variable we are having, they are making as a private here. Now you can see this. If I'm going to provide all after this particular priorities, now you can see these are all the methods here. So some of the method they are making as a static method, and some of the method they are making as a non-static method. Okay, so using this we can easily understand here. So now you can see sleep method. So they are having sleep method. Internally they are throwing a exception. So interrupted exception. Yesterday we discussed this particular interrupted exception here. Now you can see what they are doing here. Illegal. They are creating the illegal argument exception. Illegal argument exception. Okay. And internally they are calling the sleep method. So carefully observe throws keyword, how they are defining and how they are using the throw. Okay. So this is the way of writing the exceptions here. So try to focus on the one or two classes internally. You will get to know how this particular the code is implemented here. Okay, this is one of the important informations here. See, basically the thread priority. Now this is the default priority. The default priority we are having 5, because whenever the main method, because anything we are executing from the main method. So for the main method thread, what is the priority they are providing? 5 priority. But we have an option to provide the priority between the 1 to 10. This is important here. So that is I'm explaining here. So minimum priority 1, maximum priority 10. Between this 1 to 10 only, we need to provide the priority here. So you cannot use more than 10 here, or you cannot use the less than 1. So this is important concept here. Okay, so because of that only I'm explaining this. Now you can see these are all the some variable they made as a public here. This variable they are made as a public. Why they are making the public here? Because these are the constants variable. So we are not going to modify, just we'll reuse this. Just we are going to reuse this. So this is the way what are all the method we need to make public and what are all the method we need to make private. Those information we need to understand. For example, if we observe carefully, here I'm having name here, string name here. Okay, now what happens internally? The name I'm making as a private. Whenever I'm making this particular name as a private, so we'll see the set name here. Now you can see set name we are having. So this we discussed in the earlier example. Whenever we are making the variable name, variable as a private, we'll try to access with the help of the methods here. This particular behavior, we'll call it as a encapsulation behavior. Now you can see, so we're calling the public final. So name of the set name method we are calling, and we are trying to provide the name information. And the same way, we are going to have the get name here. Getting the point? So directly, instead of accessing this particular property, we are accessing through methods here. Okay, so this is they implemented the encapsulation. Now if you see the polymorphism, basically what they are doing is we define the method of this particular runnable interface, because runnable interface is a interface here. It's contain only one method. Now if I'm going to show you the where is that? I think we come to top here. Now you can see this is the interface we are having, and we are having only one method. We are having only one method, something like a run method. Now this run method we define inside the interface here. Now what I'm doing here, I'm trying to implement this. So where I'm trying to implement inside this particular thread class. So if I'm going to expand this, now we'll understand run method. Now understand here run method. So this is the simple logic we implemented here. Getting the point? This is the default logic they implemented. Now what you can do, you can override the run method and you can provide the whatever the expected logic you are going to write. Okay, this is very important example we are discussing here. Okay, and here we are accessing the encapsulation behavior. Okay, so again we are using the inheritance. Again we are using the abstraction. So all the OOPS principle we are implemented inside this particular thread class. So this is basically we need to understand here. Get in the bin. We need to understand how the class we created here. If we observe this particular class, you can create any number of classes in the real-time applications here. But only the thing, first we need to understand how we are creating, what is the purpose of this particular variable creation and the methods. Get in the bin. So that we need to understand very carefully here. Okay, coming back to here, the current thread. Now we are discussing about the max priority. Now I modify the priority here. So this is a way of changing the priority. So if you're not interested this particular max priority, now you can provide something like 8. Okay, so 8 is the between the number. Now if I'm trying to provide this, so the current thread, like after changing the information, the thread is modified with the 8 here. So the last statement, you can see this, it is modifying the values. Okay, any questions? Any questions regarding this particular current thread? Okay, so fine here. Now what I will do, I'm going to use one more method. So what is a one more method? Because in the earlier example, we already used this particular method. So we have a sleep method. We have a sleep method. Now what we are doing this particular sleep method, basically, we'll try to provide the values. The sleep method is expecting one parameter. I'm trying to give 2000. 2000 basically the 2000 milliseconds I'm giving. Now whenever I'm giving this, it is giving me an error. Getting the point? It is giving me an error. Why it is giving me an error? Because what we need to understand here, so the concept basically, the sleep method, it is trying to throw an exception here. Okay, the sleep method, it is trying to throw an exception. When this particular method is throwing an exception, what we can do? We have a two options that we discussed in the last example here. So using this particular two options here, we are going to execute the one of the options here. Now you can see I'm trying to write, either we can go for the throws declaration or we can surround with the try catch block. Now I'm trying to surround with this particular try catch block here. Okay, so now observe what I'm doing here. Here you can see what is an exception we are handling here, something like interrupted exception. Why we are handling this? So because the sleep method is trying to throw the same exception. Now you can see it is trying to throw the interrupted exception. So here inside this particular thread class, they are not interested to handle this particular throws exception, like interrupted exception. Because of that, they are trying to rethrow the exception here. Okay, they're trying to rethrow the exception. Now instead of rethrowing an exception, now what we am doing here, I'm trying to handle with this particular exceptions here. Okay, this is the way of implementing the exception informations here. Now finally, what happens internally? So if we observe carefully, here I'm trying to write one of the loop concept here. So because we'll try to understand here into I is equals to 0 and I less than, we'll try to repeat around 5 times. Okay, so just I'm trying to repeat only 5 times here. Now what I'm doing here I'm going to print this I value I'm trying to print, and here I'm going to make as a I value. So after printing this particular I value, the same whatever the thread we are using, the thread I'm going to make inside this particular loop here. Okay, inside this particular loop I'm trying to call the thread dot sleep. So observe the output first. Observe the output first. Later we can discuss about the sleep method, how it will work. Now you can see I value 0, I value 1, I value 2, I value 3, and I value 4. Now why the value, like each value, why it is taking time here? Getting the point? So each value, why it is taking the time to print here? Because what we are doing here, we are trying to make the thread to sleep. So which thread we are making the sleep here? The main thread. Whatever the thread we modified here, something like a my thread. So this is the hierarchy. Basically, whenever I'm calling this particular main method, the thread in the, so basically it start with the new. Getting the point? New is nothing but initially the thread will ready to start basically. Okay, now here we can call it as a running here. Okay, we can call it as a running. Now it will move on to the waiting state. Here it will move on to the waiting stage. Now observe carefully what happening internally. Observe carefully what happened. So from ready to like new to directly it will go to this particular running here. Okay, ready to directly it will go to the running. Now while running here, now what we are doing is we are calling thread dot sleep. Getting the point? We are calling thread dot sleep some time here. Okay, whenever we are specifying this, now what happens is this thread will come into this particular waiting state. So which thread it will come into the waiting state? Whatever the current thread. What is the current thread we are having? So initially the name we are having main. Now I modify to this particular my thread. Now what you understand here? The my thread while running this particular example, we are calling because of this particular sleep method. Now it is coming to this particular waiting state. So once a thread is coming to the waiting state, what happens internally? Once this particular time is completed, okay, 2000. Once this particular time is completed, again it will go back to the same running state. Okay, from here, where it is the runnings to waiting it came, and again, once the time is completed, from waiting to running state. Observe carefully from running to waiting, waiting to running. Why it is moving it? Because this particular threaded dot sleep we provided inside the loop. The threaded dot sleep we provided inside this particular loop. Because of this, now what happening internally? It is trying to come to this particular running, and later it is trying to move on to the waiting here. Okay, this is important. We need to understand here. Getting the point. So how we are making this particular thread to running to waiting? So sleep method. Okay, this is one of the important example, the sleep here. In the real time also, if you write this, how many threads we are going to execute here? For example, 20 threads. Okay, if this particular code is going to executed by the 20 threads here, all the threads will wait here. All the threads will wait. But it is important. Really, the threads we need to wait. We can wait this particular threads here. Otherwise, now we are not interested to write this particular sleep method. Just for understanding, I'm defining the purpose of this particular sleep method. What it will do? It will wait the current thread here. Okay. So because of this, now what happening internally? Let me run this example. Why? Okay. Now you can see again running is, so it's moving into the waiting to running, running to waiting, waiting to running, because until the time is completed. Until the time is completed, we keep on the two states here, waiting to running, running to waiting. Okay. So once this particular loop condition will fail, it is coming out of this particular line number 21. Getting the point. So this is the simple example on this particular default thread. So the default thread only, it will try to execute it by this particular current program. So any questions?
ఒకసారి చెప్తారా? కన్ఫ్యూజన్ ఉంది సార్ నాకు.
సో కన్ఫ్యూజన్ ఏం లేదు. బేసిక్గా ఇక్కడ ఏంటంటే ఒక థ్రెడ్ ఇక్కడ నాకు రన్ అయింది. ఓకే, సో కరెక్ట్గా ఎగ్జిక్యూట్ అయ్యే టైంలో నేనేం చేశానంటే దీన్ని ఇక్కడ స్టాప్ చేసేసా. స్టాప్ చేసి ఏం చేశాను, దీనికి ఒక టైం పెట్టాను. సో 2000 అని ఒక టైం ఇచ్చాను. ఈ 2000 మిల్లీ సెకండ్స్ వరకు బేసిక్గా ఇది ఏం చేస్తుంది అంటే వెయిట్ చేస్తుంటుంది ఇంకా. ఓకే, సో ఈ 2000 వరకు వెయిట్ చేస్తుంది. 2000 అయిపోయిన వెంటనే మళ్ళీ రన్ అయిపోతుంటుంది అంతే. సో ఇఫ్ ఈ 2000 అంటే ఇవ్వకపోతే, ఈ 2000 అని ఇవ్వకపోతే డైరెక్ట్గా ఎగ్జిక్యూట్ అయిపోతుంది ఇక్కడ. సో అంటే మిడిల్లో స్టాప్ లేదు ఇంకా మనకి ఎక్కడ. సో ఇట్ ఈస్ అ డైరెక్ట్ ఎగ్జిక్యూషన్ పాత్. నా ఇక్కడ ఏం చేస్తున్నానంటే నేను డైరెక్ట్ ఎగ్జిక్యూషన్ బదులు నేను అక్కడ స్టాప్ చేస్తున్నాను మిడిల్లో. సో స్టాప్ చేసి రెస్ట్ తీసుకోమని చెప్తున్నాను ఇంకా. ఓకే, ఒక టూ సెకండ్స్ రెస్ట్ తీసుకొని తర్వాత కంటిన్యూ అవ్వండి అని చెప్తున్నాను. సో అదే ఇక్కడ ఈ కాన్సెప్ట్ ఇయర్. ఓకే, వెయిట్ చేస్తున్నాము థ్రెడ్ని, దాని తర్వాత మళ్ళీ ఆటోమేటిక్గా ఆ టైం అయిపోయిన వెంటనే ఆటోమేటిక్గా అదే స్టార్ట్ అయిపోతుంది. మనం ఇక్కడ నోటిఫై అలాంటి ఏం చేయాల్సిన అవసరం లేదు, డైరెక్ట్గా రన్ అయిపోతుంది. సో దాని పర్పస్ ఓన్లీ ఇక్కడ మనం ఈ స్లీప్ మెథడ్ రాశాను ఇక్కడ.
ఏ వాల్యూ అయినా పెట్టుకోవచ్చు కదా సార్?
సో ఇప్పుడు ఇక్కడ 2000 బదులు నువ్వు ఏమైనా పెట్టుకో, కాకపోతే ఇక్కడ బేసిక్గా ఆ టైం బట్టి ఉంటుంది. ఫర్ ఎగ్జాంపుల్ ఇక్కడ నేను 5000 ఇచ్చాను అనుకో, ఈ 5000 ఇచ్చిన వెంటనే ఏమవుతుంది ఇక్కడ సైజ్ టైం ఎక్కువ టైం తీసుకుంటుంది. ఇట్ విల్ టేక్ మోర్ టైం. నువ్వు చూస్తే ఐ వాల్యూ 0 ఐ వాల్యూ 1 ప్రింట్ అవ్వడానికి చాలా టైం తీసుకుంది, అంటే అరౌండ్ 5 seconds. నువ్వు కౌంట్ చేయొచ్చు, 5 seconds వరకు ఇట్ విల్ నాట్ ప్రింట్ ద అనదర్ వాల్యూ. ఓకే, సో టైం డ్యూరేషన్ ఈజ్ ఇంపార్టెంట్. సో ఎంత టైం మనకి కేటాయించాలన్నది మనం డిసైడ్ చేసుకున్న తర్వాత దాన్ని డిజైన్ చేయాలి. ఫర్ ఎగ్జాంపుల్ నేను ఇక్కడ 500 ఇచ్చాను అనుకోండి. సో ఇప్పుడు నేను 500 ఇస్తే ఎంత ఫాస్ట్గా ఎగ్జిక్యూట్ అయిపోతుందో చూడు. 2 3 4. Okay, so it will depends on the time. So what is the time we are going to provide? Based on the time, it will try to run our example.
ఓన్లీ 5 ఇస్తే సార్?
ఓన్లీ 5 milliseconds ఇచ్చినా రన్ అవుతుంది, రన్ అవుదని ఏం లేదు. నేను అదే అంటున్నాను, ఇక్కడ టైమ్ ఈజ్ ఇంపార్టెంట్. బట్ ఇక్కడ 5 millisecondsకి నీకు ఏం అర్థం అవుతుంది? ఏం అర్థం కాదు. ఓకే, లెట్ మీ సీ, ఎక్కడైనా ఎక్సెప్షన్స్ వచ్చినా లేదు కదా. చూసుకో, 5 millisecondsలో అది వెదర్ ద స్టాప్ ఇస్ లైక్ థ్రెడ్ ఇస్ స్టాప్డ్ ఆర్ నాట్ వీ కెనాట్ ఐడెంటిఫై. సో డైరెక్ట్లీ అవుట్పుట్ వచ్చేసింది. ఓకే, ఇంకేమన్నా క్వశ్చన్సా? Now, so we understand here, this is the default thread, but how we can create a custom thread? Getting the point? So we identify some methods, we can modify the data, but I want to create a custom thread here. So what is the best way of creating a custom thread? So creating the thread, as I explained here, we have one interface, runnable interface we are having, and we are having one class, something like a thread class. So you can go for this particular interface to create a custom thread, and you can go for this particular thread class to create a custom threads here. Okay. Now what I will do, first we'll see the example on the implementing the runnable interface. Later we'll try to find out the exception here. Later we'll try to find out this particular thread classes here. So now observe carefully, I'm trying to write the simple example. It's like a new thread, and this particular new thread basically it will try to implement from the runnable interface. Whenever we are implementing from the runnable interface, what we need to override the method. So just now we discussed about the one method is available inside this particular runnable interface. So what is the name of the method? Something like run. So it is not doing anything. Okay, it is not providing, getting the point, it is not providing any return value. So just it is a void type. Now observe carefully, this is the runnable interface we are using, and we are having one method called the public abstract void method. So it is an abstract method. So abstract method basically it will not contain the method body. Now what we need to do, we need to override this particular method here. Okay, now what you understand here, whenever we are overriding this particular run method, what we can do, we can write the logic whatever we want to execute here. Okay, so this is important here. Now observe carefully, thread T I am declaring. So once a thread T I am declaring, I'm trying to come up with a public and new thread. It is a constructor. Getting the point? It is the constructor I'm creating. So here create a new thread. Okay, so here we are trying to create a second thread. Getting the point? Instead of new, second we can call, because already first thread, what is the first thread? Main is the first thread. First thread is the main and the second thread we are creating here. Now finally, what I will do, here I'm going to write the creation of thread. So how I'm creating? T is equals to new thread I'm creating. Getting the pen. So here I'm trying to create a thread information. I'm passing this. So this is the one constructor, and here I'm trying to providing demo thread. Okay. How many parameters passing to this particular constructor? 2 parameters. So why I'm passing this particular 2 parameters basically here? Why I'm passing these 2 parameters here? This is important. Here I'm passing the current object with a thread name here. Now if you go to this particular constructor, first parameter runnable interface is expecting. Second one we are passing as a name of the thread. The name of the thread we are providing as a string, okay, and a runnable interface. So internally it will calling the one more constructor which is expecting 4 parameter. First parameter null, second parameter target, third parameter name, fourth parameter 0. Okay, so we'll see later what is doing internally. But now come back to here. I'm trying to create a one second thread here. After creating this particular second thread, here I'm going to print the message here. What is the message we can print here? Something like this is the child thread basically. This is the child thread we are printing. What is the main thread? Main thread is coming from the main method. Child thread only we are creating from the new thread class. After creating this particular thread, we need to start the thread. Whenever we are starting this particular thread, what happens internally? It will try to call this run method. Okay, whatever the run method we defined here, this particular run method will call here. Now what I will do, I will go to the current thread and I will copy the same code. So I'm not defining much code inside this particular run method. Just whatever the code we identified, like whatever the code we executed inside this particular run method, the same, getting the pen, the same code here I'm trying to execute here. Okay, the same code here I'm trying to execute here. This is one of the important example we need to understand here. Okay, after executing this, I want to modify some informations here. Here I value with like okay, child thread I value. Okay, child thread I value I'm providing it, so that because this run method is called by this thread, whatever the newly created thread we are creating, the newly created thread only it will try to call the run method here, not the main thread. Whatever the main thread we have seen inside the main method, the main thread will not call this particular run method. Getting the point? This is important. So why it will not call here? Because internally we are creating one thread here. So we are printing the thread information, and here we are trying to start the thread, the child thread here, not the main thread. So you can see 3. This particular T, it is referring to the child thread here. Okay, this is important here. Now, what happens internally? What I will do, I will go to the main class here because we need to create the main class. So now let me create a main class here, and here new thread demo. Okay, so new thread demo I'm creating, and I'm trying to click on the finish here. So once we click on this particular finish, getting the pen. Once we click on this particular finish, now what I will do, I will go for this particular new thread here. New thread here. Okay, so this is just I'm calling the child thread. Observe carefully what we are doing here. We are trying to call this particular new thread. After calling this, I'm copying this. Okay, so don't confuse here. This try block is executed by the main thread. Okay, this try block is executed by the main thread here, and inside the run method what we provided, so that one is executed by the main thread. I'm giving as a 5,000. Okay, so to understand easily, so child thread I'm going to give as a 2000. Okay, child thread I'm giving as a 2000. So this is important example here, so that we can easily understand here how this particular two threads are executing. Here not only one, we are having two threads. So let me run this example. Observe main thread I value, child thread I value, and I value 1 and I value 2 is printed. So main thread I value 1, because the main thread what we did, we given some more time here, because of that child thread is executing fast. Okay, so still main thread is trying to complete one more. Now the main thread is completed. Observe carefully. So child thread. Okay, so child thread I value 0, child thread I value 1, 2. After this, the main thread is printed. Later, child thread 3 and 4. Later, the main thread. Because main thread we given as a 5000 time, and the child thread we given some less time here. Because of this particular less time, it is trying to execute, like it is trying to execute little bit faster compared to their main thread. But what we need to understand here, this is important here. So the child thread creation, this is the way of we can create. But what we are doing it, we are implementing this particular runnable interface, and run. Once we implement this runnable interface, we need to override the run method. Whatever the logic we want to execute, the logic we need to write inside this. So this is the logic is executing here. See, we are not going to get semantic order. So as I explained here, it will not follow the rule like first you execute or later I will execute. So this is not the order. Whatever the threads we are creating here, it will try to run on the separate path of execution. It will not depend on the other threads here. Getting the point? Here we are having two threads. Once two threads are started here, it will try to execute their own path here. It will not check about the what happening next. Okay, so if I want to give this 2000 to the main also, now you cannot understand what happening here. Getting the point? Because what happens internally, because of this particular separate path of execution, so it will try to execute differently here. Now you can see, because of this time, so this is happening like child thread, main thread, child thread, main thread. Now you can see here, child thread is executed 2 times. But here the main thread is executed later. Okay, same way. So main thread I value 1, so main thread I value 2, so child thread I value 2 and 3, so main thread 3 and 4. We cannot identify how this will execute. If I'm going to give something like 5, here also I'm going to give something like 5 here. The 5 milliseconds, now you can see how this particular example are working. Okay, here also you can see child thread 0, 1, main thread is executed 2 times, again child thread and main thread, child thread and main thread. Because of the separate path of execution, it will not check about the what happening internally. Because what happens basically here, this we need to understand carefully. Here, where is that? Yeah, here. So inside this particular main method, this object is created by main. Just it is the constructor is called by the main. That's it. The main thread, it will not do anything here. Because after creating this particular constructor, what happening internally? What happens internally basically, it will come to this particular new thread here. Okay, this constructor will call, this line will execute. The 3 lines. Once this particular 3 lines is completed, it will come back to the line number 10 and it will come back to this particular 7 here. So the main thread operation is completed. Okay. Once a main thread operation is completed, now what we need to understand here, this particular code is going to executed by the main thread here. Here we don't have an option to execute by the child thread. And here what we are doing is, we are calling this particular t.start. Whenever the main thread is going to call by the t.start, the child thread is going to active now. When the child thread is active, it will try to look up this particular code. Okay, when the child thread is active, it will look up the code. For example, if I'm going to comment out, this particular start here. Now you can see What happening internally? Only main thread is executing. What about this particular child thread? So child thread is not started. Just we created, but we did not start it. Okay. So this is very important example we need to understand here. Whenever we are creating the child thread, we need to start here. If you are missed to start here, it will not run our child threads here. Okay. Any questions? సాయి ఏమైనా క్వశ్చన్స్ ఉన్నాయా? Okay, so now what I will do, this is implementing from this particular runnable interface we identified. Now we'll discuss about the extending the class. Getting the point? Now we'll discuss about the extending the class, how we can write here. So that is also I'm going to write the another example. For this example, extending thread. So new thread we cannot create here something like what is the name we can take, something like so extend thread I'm trying to take it because this is the thread we are going to extend from the our thread class here. And here now what I'm doing here, I'm trying to extend from the thread class here. So once we extend from this particular thread class here, now what I'm doing is I'm going to write the constructor. So this is very important constructor we are defining it. So internally what I'm doing is, so anything I'm missing, extends, not extend. Okay, extend thread. And internally what I will do, here only I'm trying to write the keyword. What is the keyword I'm using? Super. This is important here. I'm going to provide the same, the message I'm going to give same. So observe carefully, here I'm calling the super keyword. Why we are calling the super keyword? Because earlier example, we created object with the help of this particular new keyword. But right now, we don't want to create the new keyword because, so anyway, we are extending the thread here. Whenever we are extending the thread internally, the thread class will create here. Because of the particular inheritance here, first it will give the option to create the super class object here. Later, it will come back to the subclasses here. So this we discuss the constructors information. Okay, how the constructors will call? First, it will give the option to execute the superclass constructor, and later it will execute the subclass constructor. Okay, so here we are doing the inheritance. So now we don't want to create the object with this formality. What have you given? This formality. So new thread something like this. Okay. So this is, here we did not extended the thread class. Because of that I created object here. But whenever we are extending from the thread class, what we can do directly, we can call this particular super, it will create an object here. Okay, after creating this, now what I'm doing here, I'm trying to print this, sorry. Child thread, and here I'm going to provide as a this. So this is basically current class object. Getting the point? This is important. Now we discuss this keyword in the earlier example for the variable level, method level. Okay, same way here what we are doing here, we are trying to use the current object here. We'll print the current object, and later I'm going to call the start method. I'm going to call the start method. So once we call this particular start method, now what I'm doing here, I'm going to override the run method here. So this is the run method I'm overriding. And here I'm not interested to give the option to execute the superclass run method. I don't want to execute the superclass run method because here I'm writing my own logic. Getting the point? Here I'm writing our own logic here. I want to execute our own logic here. So this is the our own logic I'm trying to write here. Basically, what happens here, if I'm not overriding this particular run method, what happens internally? The run method, it will call from the superclass run method. So they did not implemented much code because, so just they provided the basic implementation part. Can you understand? They implemented the basic implementation. Now, what we can do, we need to write our own logic here. So because of that, I'm trying to override the run method. I'm implementing this. Okay, it's a simple one. So compare here, just we are calling the superclass constructor and we are printing the current class object here, and later we are starting this particular thread. Okay, so this is the way of writing this particular extending the thread, and same thing I'm going to call from here. From here only I'm going to call here, just to modifying the new thread. Instead of new thread, I'm calling the extend thread. That's it. I'm not doing anything, just I'm printing this. Whenever I'm printing this, now it will call the extend thread and it will print the demo child thread. It is printing demo thread, and the main thread and child thread it is printing. So what we need to understand here, the differences we need to understand basically. Okay, how this particular differences are going to work internally, that we need to understand here. So now the internally, whenever we are implementing this particular runnable interface, so we are going to create object like this, and whenever we are extending the thread, so this is the way of creating the the way of creating the child threads here. Okay, so any questions regarding this particular thread class extending? Okay, so if it's clear, so which approach is the best one? Getting the point? Because we discussed the two example. Which approach is the best one? Basically, so runnable interface, basically we have only one run method. Now what happening internally, the run method, getting the point? The run method basically internally, it is trying to we are overriding, and we don't have a other option to modify the thread functionality. Getting the point? And thread class can contain the several methods. The several method we discuss here, and where is the current thread example. So inside this particular thread class, now what happens internally, we have these many methods like set name, set priority. Okay, so join dot sleep. Getting the point? So this particular thread dot sleep method we are having. These are coming from the thread classes, not from the runnable interface. So whenever you want to work with some additional methods here, getting the point? Whenever you want to work with some additional methods, now what we can do, we can go for this particular thread class. Otherwise, I don't want to modify the information directly. I can use the whatever the default functionality which is going to provided by the thread class. Now what we can do, we can go for the runnable interface. And whenever you are using this particular runnable interface here, so here we have another option to extend one class here. Okay, here we have one option to extend one class. Any class we can extend here. But when we are trying to work with this particular thread class, we don't have an option here. This is also important here, because extends keyword will work on only one class. Getting the point? This is important here. The extends keyword will work on only one thread class here. That is important here. So you cannot extend more than one class. But here we can implement more than one interface. We can implement more than one interface. This is applicable. And implementation, whenever we are implementing this, we can what happens internally, we can extend one class also. So this is some additional benefits we may get here. Whenever we are implementing this particular runnable interface here, what happens internally, we have an option to extend one class here. But the extend option, we are not going to get from the runnable interface here. This is very important example we need to understand here. Okay, this is all about the simple example on thread class as well as runnable interface here. So is it clear?
సార్ 17th వచ్చి ట్రెంట్ వాల్యూ అట్లా ఇవ్వచ్చా సార్? ఇప్పుడు స్లీప్ ఇచ్చారు కదా, ట్రెంట్ వాల్యూ ఇంకేదైనా
స్లీప్ బదులా
ట్రెంట్ వాల్యూ అట్లా ఇస్తాను సార్.
అంటే అర్థం
ఇక్కడ
కాలేదు.
వాల్యూ ట్రెంట్ వాల్యూ, ఇప్పుడు ట్రెంట్ స్లీప్ అని ఇచ్చారు.
ఓకే, థ్రెడ్ డాట్ స్లీప్. సో థ్రెడ్ డాట్ స్లీప్ బదులు ఇంకా ఏమైనా ఉన్నాయంటే ఇక్కడ చూసుకోవాలి మనం. ఒకటి కరెంట్ థ్రెడ్ ఉంది, యాక్టివ్ కౌంట్ ఒకటి, సో డంప్ స్టాక్ అని ఒకటి ఉంది. ఓకే, సో వీ హ్యావ్ సమ్ డిఫరెంట్ మెథడ్స్. దీస్ మెథడ్స్ వీ కెన్ యూస్. బేసికలీ క్లాస్ బేస్ చేసుకొని మనం దీస్ ఆర్ ఆల్ ద స్టాటిక్ మెథడ్స్ అండ్ ప్రాపర్టీస్. what are the static properties we are having, we can use here. So we can go for the active count. Okay, it will return the, what is returning? Int it is returning. Getting the point. So this is also, let me write this. Here I will provide, instead of this particular thread.sleep, we can go for the active count. Active count will give you the, how many threads are in active. Okay, it will give you the count here. Okay, the particular count you can print here. So this is the another method. So same way, thread dot. Now we discuss about the all the priorities, current thread, dump stack. So basically, what exactly it is will do this particular dump stack. Here you need to read this. So print the stack trace of the current thread. Get in the bit. It will try to give you the information about the current thread here. So now you can see internally, it is calling the exception class. Getting the one. Now you can see here what we are doing here. We are creating an exception object. We are not throwing an exception, just we are printing exception object and we are trying to call the printer stack trace here. Okay, this is the another method here. So for example, where we define, here we define. Now let me go for this particular thread class. Now you can see what happening internally. It is printing the stack trace information from where to where it is calling and which line it is executed. Every information it is printing here. Because why it is printing these many lines here? So we define inside this particular loop here. We define inside this particular loop. So this is the dump stack will do this particular messages here. So it is the count. Sorry, where is the count? I did not print here. If I'm going to print this count here. Now we identify this particular dump stack. We have a lot of method we have, but only so we need to practice well. Then only we'll understand how this particular all the methods. Now you can see, so count is 2. Okay, all the ways I'm getting count is 2. Why I'm getting this particular count is 2? Main thread is one child thread we are having. Getting the one. These are all the active threads counts. So this is the way of finding the how many threads are running in our current program using thread dot the active count here. We'll see the remaining methods, but so this is the way of accessing the static method. Thread dot active count, thread dot sleep, thread dot dump stack. Okay, each method will do the different operations. So that we discussed in the previous example here. Same way in the thread class also we are going to have multiple methods here. Okay, is it clear? Okay, so if we don't have anything else, so today evening I'm not going to take the session, like we'll continue tomorrow. The tomorrow session will be the 7 a.m. Okay, so this is important here. Tomorrow we'll connect it to 7 a.m. here. Any questions? Have questions or sign?
No, sir.
Okay. Okay, so tomorrow we'll continue.